going to moderate this amazing debate.
Okay, thank you, Tim. So to round out this mini-conf, we thought we'd get two of the people that are representing, in my humble opinion, two of the more exciting distributed storage technology projects that are in the open source community today, and let them have a go at each other, which is exactly what we're going to do now. So let me just start by introducing the most important people on the stage here today, which are my two debaters. To be fair, in alphabetical order by surname. John Mark Walker in the Gluster camp, and Sage Weil in the ceph camp. Now let me introduce these guys to you real quick. John Mark is I think it's fair to say, a veteran community person in the free and open source software space. I know that's dating you to a certain extent, but you're just going to have to live with that. If I got your biography correctly, you spent a significant amount of time at VA Linux, correct? And that's basically, he was in the SourceForge and Slashdot and whatnot space for quite a while. SourceForge, that's right. Before joining then independent Gluster Inc. And then he was to be apprehended along with the rest of Gluster by some secret agents wearing red headgear. He is based on the US West Coast. East Coast? What was that? You moved last summer. Okay, my information is outdated. What I do know about John Mark, however, is that he's not exactly a person who is known to keep his views to himself, which is quite evident from his Twitter feed. He has relatively strong opinions on US economic policy. It's quite interesting to follow. He is also, and I hope this is not wrong, he's also an avid follower of what one half of the English-speaking world calls association football, and the other soccer. Sage Weil, to my right and your left, is the technical lead of the ceph project. He is one of the founders of DreamHost. It's a hosting provider located in Southern California. And in the mid-2000s, took a break for some postgrad work at the University of California, Santa Cruz. And this work resulted in a PhD thesis, which ultimately became the basis of what the ceph stack is today. Since 2012, he's been in a leadership role at Inktank, which is a company that spun out of DreamHost in order to build a support and services business on top of ceph. He's based in LA. Sage is a strong proponent of a standing desk arrangement in his office, which makes video calls with him really, really interesting in a hoppy, bouncy way. He has a gigantic whiteboard behind him to draw out his design and implementation ideas, and rumor has it that this whiteboard has never been empty. As for myself, I'm Florian. I run Hostexo, which is a company that does projects with both of these storage technologies. And I will be doing today what is the absolutely hardest thing for me to do on anything, and that is have no opinion and shut up. A few words about this format that we're doing this afternoon. This is a debate, which means it's not a Q&A session, and it's also not a fight, but something halfway in between. We're going to start with giving each of our presenters 3 minutes and no slides to give us their summary of the project that they represent. And after that, we will start with the questions. And whenever you have a question, then please just raise your hand and wait for Tim to race up to you with the microphone. And of course, when you have questions, then please try to be as precise as possible and put our speakers on the spot. Huh? We'll kind of try to alternate who's the first person to answer the question, and the other person will always get a chance to answer or rebut or whatever they choose to do. Heckling is perfectly allowed, as long as it's good-natured and as long as we are being excellent to each other. You done yet? Almost. Almost. So before we dive into our questions, every one of our two speakers is now going to get 2 minutes to describe what they think, 3 minutes, I'm sorry, to describe what they, wait for a second, you get 1 minute. To describe what they think is what everybody should know about their project. And in the interest of fairness, I thought we were going to do a coin toss to determine who goes first.
The suspense.
So let me pull out my, there we go. What, seizure?
Seizure. Yeah. Oh, that.
There we go. Okay, John Mark, heads or tails?
Heads.
Heads. There we go. And it is heads. John Mark goes first. There you go.
Greetings. Do I need this thing to be on, or is it necessary?
Yeah, for the video.
Okay, I'll just try to hold it down. Thanks. Yes, my name is John Mark Walker. I'm the Gluster community lead. There are a few things that you may not know about glusterfs. Let's start from the beginning. It had kind of an interesting beginning because we never set about to be a storage company when we were Gluster Incorporated. We never set about to write a distributed file system, at least not initially. Some would say that that's apparent in the current code, but I would disagree with that. But seriously, from the beginning, we were we were responsible for creating clustering software for HPC solutions, and a lot of that was for oil and gas companies. And then one day, I think in around 2006, 2007, there was a company, and it was an oil and gas company in South America. They needed something done. They said, hey, by the way, can you do this distributed storage thing? And we did it in 6 months. And being a cash-strapped startup, as cash startups do, we said, yes, of course we could do that. Not really understanding at all what that would entail. So we thought we would just pick something off the shelf, install it, get going, and be fine. It turned out it wasn't that easy. We tried to do something off the shelf. We discovered that proprietary software was extremely expensive and difficult to use, especially for that use case. And one thing about it, the great part about it was the performance requirement was it had to be faster than tape backup. As long as it's faster than tape backup, we were good to go. So had to be distributed, had to be elastic, had to be able to add and subtract data, and had to be faster than tape backup. So we decided that after running through a bunch of different solutions that didn't work, we thought, and I can get into exactly what they are later, but it's not important now. But we discovered that, okay, we'll do this thing. And we found out that the best way to do this was we'll just implement our own solution, and we'll create what we called a Lego toolkit for building file systems. And this gets into one of our primary design principles, which is glusterfs itself is not a file system per se. It's a toolkit for building file systems on top of a messaging framework. One of our co-founders, A.B. Periosimi, was a contributor to the GNU Herd project. How many have heard of GNU Herd? Okay, good. I figured this audience, you know what I was talking about. Some people view that as a positive, some people as a negative, but it really did inform our early design decisions because we decided it's all going to be user space, and that's what we're creating message passing interfaces between translators in user space, and around that, build schedule to determine distribution of data.
Time's up.
Okay. Yes.
Troy,
Is this better?
Yeah.
Okay, so I thought you were about to yank me off stage.
Time's up. Time was actually up before the interruption, so we're cool. All right.
All right. My name is Weil, as you know. ceph actually started as part of my graduate work at AC Santa Cruz. The motivation was that the national labs are deploying these huge supercomputers, thousands, tens of thousands, hundreds of thousands of processors writing to the same file system at the same time, dumping these huge, computations into the system. And the problem was that the Lustre metadata server just did not scale. It was a single node, it was a single point of failure, and it didn't perform. And so we were sort of tasked with how do you build a petabyte scale file system? At the time, petabyte was the big number. How do you build a petabyte scale file system that will actually scale to those workloads? And as we sort of took a step back and looked at sort of the larger design problem, we realized that we needed to solve a couple of different problems. One is just the scalability aspect. How do you make something that actually will distribute that workload across lots of nodes and still give you the right answer? Another was that when you're dealing with systems at scale, other things become important. You need to have fault tolerance needs to be dealt with as a first level concept, because any system that has that many moving parts, some of those parts are going to be failing at any point in time, and you need to be able to be continuously available and working even in the face of those failures. And finally, of course, performance is important. And so out of that sort of effort, building initially the metadata server and then wanting to implement it and needing something for it to sit on top of, we ended up building an entire distributed object layer that we called Rados that will actually replicate trillions, bajillions of objects across thousands of nodes. And then on top of that, building the parallel file system and with the whole distributed metadata server in order to actually solve that problem. And then when I finished my dissertation work, I sort of naively thought that all I have to do is open source this and people will start, hacking on it, and then I'll be able to go do something else and move on with their life. Didn't exactly work that way. But what I observed in grad school is that all of my peers who worked on these great graduate student projects, as soon as they finished, they'd go get a job at NetApp or an EMC and so forth, and they would stop working on these new interesting models that were open source by virtue of being research projects, and go work for the devil effectively.
Sorry to interrupt. We might move the mic a bit. It's very, very muffled from that.
I agree. Yeah, sure. Is this better? Yes. All right. And so what I found is that we're trying to build a system that was scalable and had sort of the features that you could. I have to hold it closer. Yeah. Build a system that was scalable and high performance and had all the features that you would need out of an enterprise storage system, but didn't cost thousands and thousands of dollars per terabyte, however much it was at the time. And there was nothing like that available. There were no open source products that would compete with what you get from a NetApp appliance, which was prohibitively expensive for most people. And so I decided to, instead of going to work for EMC and drawing a salary, to take the open source route and try to make this into something that could compete with something real from the open source community that would actually compete with the enterprise options, both on feature set and on price, and on, of course, the principle. And so that's sort of where Ceph is today. Since then, it's evolved from something that was purely a distributed file system to something that has, a file system client in the Linux kernel, a Fuse client, a library client, also a distributed block layer, fully featured, and also a distributed object storage layer. So everything all in one, and it rules.
Time's up. All right, thank you. So to give our speakers a bit of an idea how well each of our technologies is already known to the audience, we're gonna quickly conduct a quick poll. Okay, here's how this works. This is something fantastic because it's completely anonymous and private, because we don't want our speakers to know who is in what camp. So it's called the humming poll. Okay, I'm gonna ask you a yes or no question, and if the answer for you is yes, you hum, and if it's no, you stay silent. Okay? So let's test this real quick. Who in here is currently physically in this room? Okay, universal agreement. Okay? Who in here has traveled here from someplace outside the Australian mainland? Okay, that's less. All right? So that's how this works. So question number one, who among you has previously used in any fashion, whether in production or testing or whatever, who of you has used glusterfs before? Okay. Who of you has used ceph before? Who has used both? And who has used none? Okay. See? There you go. Okay? So we have a rough understanding of who has used what and how familiar you guys are with these technologies. Thank you for that. Okay, and since John Mark started with the introduction to the project, Sage now gets the first question. Now, would you please read out your T-shirt?
Your distributed file system sucks.
Okay. And now, the first question for Sage is, back up your T-shirt, and then for John Mark is going to be, rebut Sage's T-shirt. Go.
I'm kind of a nice person, so this is going to be a little bit challenging. I think one of the key differences you'll see between what glusterfs offers and what ceph offers is a design that sort of is born out of a long-term sort of design effort where you're saying, taking a step back, how would you actually build something that actually makes sense and solves a problem? Versus, how do I build something in less than 6 months that I can immediately move into production that is as simple and faster than tape? I think if the bar is low, then you get what you pay for.
I think that's actually pretty close to accurate. I'm not gonna no, but seriously, glusterfs was designed to be easily usable, easily managed, and it was really about simplicity, and that was the design goal originally. We're big admirers of ceph, we're big admirers of Tank. We're very hopeful for their success, to be perfectly honest with you. The reasons to use glusterfs as opposed to anything else would be because of that simplicity, that ease of use. The unified data backend that we're building, whether it's an object-based interface that's based on the Swift API, or whether it's the new KVM integration we're doing that will finally allow people to host VMs on glusterfs in a way that performs up to expectations, to the scale-out NAS file system that we built. All these were designed to be, a unified way to store your data your way, not dictated by some vendor. And really, we're going after EMC. We're going after other open source projects. I think that all of us, working on different open source projects, are going to be able to do that.
By the way, I just have a set of questions here that basically come out of a common thread on my Google Plus feed and whatnot. So I'm just going to go through these as long as we don't see hands coming up, but please don't take that. There we go. There's Joe.
Okay, question. Good, Don. Question for both of you. You cannot use your distributed file system. You must use someone else's. Which one do you pick and why?
Depends on the use case.
So we said we're going to alternate, so it's you go first, Joe.
Okay. Depending on the use case, I would think that there are times that I have recommended ceph to people, especially for cases where they want to do some image hosting on a distributed network.
Yeah. So I think two things I want to say. First is that I think there are a lot of different use cases, and glusterfs and ceph are better for different use cases. They have their strengths there, certainly. So if I weren't using ceph, I would probably be using glusterfs, because I think the key thing that I don't want to use is an expensive appliance that isn't free and open source. Particularly when you need a scale-out solution, buying boxes to actually do that is typically not cost-effective. It's cost-prohibitive.
Okay, this is going to get a bit of blood on the dance floor, but what do you think, this is for both of you, what do you think is the worst thing about your opponent's distributed file system?
Sage?
This is hard because I actually don't know a lot about the technical details of how glusterfs is implemented, but I can ask some pointed questions. I have heard that
From a friend.
So one of the things that glusterfs does that ceph doesn't is geo-replication, replicating across multiple data centers, and I've heard that's based on rsync. And I have a hard time believing that you can have a geo-replication solution that gives you actually a consistent disaster recovery backup that is based on rsync. But maybe that's okay. I don't know.
Can we go ahead and answer that?
Sure.
Yeah, sure. So geo-replication is it's an asynchronous replication. It's eventually consistent. Rsync is used as sort of the actual copy mechanism for the bytes to go over to the replicated volume, but it's not. The brains are not rsync. In fact, we only use like the very minimal part of rsync to actually move the data. Before that, we have like a marker API, a marker framework that keeps track of data changes and manages which changes are going over to the next volume.
There's like a in-memory log or something like that that's keeping track of what's...
Yes, exactly.
Okay.
Unfortunately, I have to also say that I don't actually understand a lot of the technical details of the ceph implementation. I've never actually deployed ceph. I only know what I only know what the piston guys say. But yeah, I don't think it'd be fair for me to answer that because I'd be talking my ass.
Are you guys going to disagree on anything?
You have to ask some pointed questions.
So I have one question here that is probably going to spark a little bit of disagreement. One of Linus's rather memorable LKML quotes is that you shouldn't be doing a file system in user space for anything except toys, but we also know that Linus is admittedly not an authority on storage, right? So we shouldn't necessarily take his opinion as dogma. And conversely, there's been some recent benchmarks from the Gluster camp that have shown that at least in some workloads, glusterfs is actually faster than ceph. So, John Mark, how would you dispel such FUD from admitted non-authorities, like Linus? And Sage, how would you shoot down what would be an outrageous performance data rigging attempt if Linus is right?
Yeah, we had a nice rebuttal to Linus's, or AV Parasite, I should say, had a nice rebuttal to Linus's user space file system for toys. That's because Linus has never actually built one. So,
fair enough. I mean, most of what Linus says about file systems is completely wrong when he's talking about distributed file systems or local file systems.
Mm-hmm. Non-authority, that's what I said.
So I think whether you're talking about, when it comes to distributed file systems in general, I think you have a hard time living inside the kernel. And I think that's, no matter what orthodoxy you happen to follow, I think that's the conclusion you'll eventually come to. I understand ceph has like an internal client implementation, but I think Sage would agree that for the most part, especially with the non-client part of things, it makes it a lot easier to be in user space.
Yes, definitely. So one of the real problems that Lustre had, for example, which is sort of one of the earliest sort of big parallel file systems that was object-based, sort of, was that they'd put everything in the kernel, both the server side and the client side, and it became this huge bloated disaster. And I mean, there are many other problems that sort of came in along the way. And so we deliberately try to keep most of the server side out of the kernel. But I think for the client implementation, that's sort of the one time when it makes sense to sort of closely integrate with the VFS. All that being said, I think the whole in-kernel versus fuse question is really just a red herring. You can make perfectly usable systems that are based on fuse, and you can make perfectly usable systems, obviously, that are based in the kernel. It really depends on what your use case is. So there are weaknesses in the fuse API, and so there are certain corner cases where there are limitations. But fuse has really come a long way since Linus made that comment, and even previous to that. So it's much less of an issue today than it was before. As regards to the performance information that Florian was alluding to, it's funny that the fuse topic even came up in that discussion, because the performance numbers that was based on had absolutely nothing to do with the fuse implementation or whatever. It was really about the performance on the actual storage nodes and how we're actually writing things to disk. And basic decisions that ceph made as far as how it writes things to disk and how Gluster does it. And that's what's sort of responsible for that disparity.
So Sage, you mentioned Lustre a couple of times, which is pretty good at sort of streaming writes and that sort of workload. How close do you think you can get to that in terms of performance once you add all the bells and whistles like replication and copy and write and all that sort of stuff?
Ceph today can't get anywhere close. And the reason for that is because Lustre has been used exclusively in the HPC community, where they cared about nothing except for numbers. And so they've been relentlessly tuning it on both the network side and on the storage side for almost a decade. And we haven't really done any of that, so we have a long way to go. That being said, it's really based, the architecture is a completely different use case. In the Lustre architecture, there's no fault tolerance at all. So in order to make a highly available system, you actually have to buy expensive like RAID arrays or SANs and connect them to multiple hosts, and then have some like IP failover hack to make them. And and then you have this expensive networking layer, and it's a very expensive process to actually make it go that fast, but they do it. I think both ceph and Gluster have taken the alternative approach where you actually want to build something that's cost effective and scales both monetarily as well as physically or technologically, I guess. And so it's better to do that sort of redundancy in software. But we haven't really invested the effort in tuning and so forth. So
John,
once we get to that point, obviously we'll.
I just want to respond a little bit to that, because while Lustre is very performant for its particular use case, when you start scaling beyond a certain point, Lustre starts to fall over performance-wise. One of the reasons we chose the design we did was because we can scale pretty linearly beyond a certain number of nodes. We also skipped the whole metadata server bit, which Lustre, I think, still uses. And that we're posing a hard limit on how far you can actually scale and still perform up to the level you did at smaller loads.
And for HPC, metadata server isn't a problem, because what they did, terabytes.
Sort of.
In most cases, it's not a problem. So they've just designed around that.
Sort of. for certain applications, the file system people have beaten the application developers over the head long enough that they actually write into large files. But most of the codes that those HP folks are running are like decades old. They're written in like Fortran 87 or whatever it became before that. And they actually, they do horrible things to the metadata server. So it's surprising that Gluster is less. Yeah.
Okay, we'll take another question over there, and then we had one here.
Curious about RDMA and what you see the role of RDMA and intelligent networking playing in both Gluster and ceph.
I don't understand the question.
The use of RDMA.
Oh, RDMA. Yeah, okay. But we support it. We generally try to push people into the fast Ethernet and fast switching, but we do support RDMA. But for the most part, I think our users get better performance using IP over IP. So that's kind of where we are at this point. I think for 3.4 we'll have better performance for RDMA, but yeah, it's there.
Ceph doesn't support it yet, so chalk one for Lester. That said, it was always the intention to eventually support it, and so all the networking communications stuff is cleanly abstracted in Ceph, and so somebody can write RDMA. But nobody who works on Ceph right now is a networking expert, and so we don't really have any business trying to write that right now. There are a number of people who are interested and who keep talking about it, and I keep waiting for them to pony up a developer and actually do it. But I think this will be the year.
But for most use cases, fast Ethernet is getting fast enough for most workloads. So it's at this point, we really have to weigh the return on investment to put more into developing a better RDMA solution.
It's really the HPC people who want the RDMA stuff for the most part, and occasionally some people who are building high-end appliances doing I don't know, database stuff or something.
Question over here.
Yeah.
So you alluded earlier to the fact that you like to talk about politics. So let's make this a political debate. Don't you really feel like you've sort of split the left? I mean, would we not be better served if Gluster just surrendered and you all worked on ceph? And you doubled
No, I disagree with that.
Why? What is the benefit to the community of having two?
The benefit to the community is that we can both make each other better. I mean, I know that there are things that I see like Ceph doing that I think, yeah, we should have been there, But, but I think we push each other, and I think it was so the performance question that Florian alluded to earlier was because we had an engineer who got tired of hearing about how great Ceph was, and so he decided to publish some completely unbiased information on his blog, and it just got picked up, of course. And
the Gluster blog.
Jeff, please don't do that again. But that aside, we push each other. We're friends, and we appreciate that, and I think we can both benefit from that. You guys benefit because you get two projects that are pushing each other, and the winner ultimately is you. So I chalk them up for the audience there.
I agree with that. I think that Linux is much stronger because you have X3, X4, XFS, ButterFS, and a whole bunch of others that hardly anybody uses. Than if everybody were investing their time in X4.
So kind of looking into that question, we had one question from Roger Donaldson, who sits up in the middle. What characteristic or property of the other project do you wish yours had? Sage.
So both Ceph and Gluster claim some sort of pluggability. Ceph has this concept of object classes that lets you embed code into the object layer of the storage system so you can run computation close to the data. Gluster, entire stack is this modular layers that lets you sort of arbitrarily compose things almost, and it's very, very flexible. I admire that it's easier to implement sort of high-level new features in Gluster because of the simplicity, although I also acknowledge that because of that simplicity, you don't always get the optimal behavior. It doesn't always perform or isn't as efficient or the way you'd like it to be. In Ceph, on the other hand, because it's more of a monolithic architecture, in order to implement something new, it's a lot more work. And the system is a lot more complex, and so it's harder for new people to contribute. So I'm definitely envious of the ease with which people can contribute meaningful new functionality to Gluster.
And for our part, we admire the sort of elegance of the ceph architecture and how it's been implemented. I think it's very clear, the design was very clearly informed how it was implemented over time. And you can see that in sort of how it's done.
It's quite a debate.
There's a question in the middle, too.
Yeah, from what I can tell, there's a very different approach to consistency, and you have the elastic hash, and you went with a metadata server. Could you argue for one over the other?
I'll start, I guess. So I think in any distributed system, or specifically in the file system space, there's a fundamental choice you have to make. You can go with something that is simple and consistent and very slow, or you can go with something that has caches to improve performance and simple but inconsistent, or you can go with a high level of complexity in order to get both the caching and the consistency. And with ceph, we definitely went in the direction of more complex in order to get all of the coherent caching and complicated locking protocols in order to get sort of strong coherency and strong consistency in the metadata layer. And that's a huge investment in both complexity engineering and testing, and now in stabilization. Now we have to actually make it reliable and so people can use it in production. I actually forgot what the question was.
Yeah, I mean, the reason we bypassed the whole metadata server bit was because we found that we were able to push the scalability beyond a certain point more easily. And really, specifically, it comes down to the scale-out NAS use case, and that's really where we came down to the DHT, the elastic hash solution. And for those of you unfamiliar, basically the way we bypass a metadata server or service is by doing a bitwise hash of the file name. And that's how we calculate where the data is stored on a distributed volume. We found that using that methodology, we were able to scale out to pretty large amounts and still maintain the performance level that was expected. Originally, we didn't rely on DHT. We had about 9 different schedulers, and some of them were implemented by different developers. Because originally, we were very much a hacker's file system, and we didn't push people to any one scheduling system, so people could choose whichever one they wanted. Over time, though, we solidified around the DHT solution that seemed to serve as best specifically for that scale-up NAS use case.
Yeah, I think glusterfs. I think there are 2 paths you can make. You can make something that is simple and robust, and you trust it and it's reliable and it works really well. And I think that is why glusterfs is very stable in production today, and people can run it. And you can also go with a much more complicated solution that tries to do a lot more, and it takes a lot longer to get there because it's much more complicated. And that's pretty much where the ceph file system is today. And so I don't think either is the wrong solution. They're just sort of different paths, and it's good.
Mr. Right and one Mr. Right now.
So the interjection, just so we have it on video, was one is Mr. Right and the other is Mr. Right now. Go ahead, John.
I was just going to point out that there is a developer in Spain who's actually doing a new way of doing distributed replicated volumes, totally independent of our efforts. And so I'm curious next year when we have this discussion what they're going to come back with, because it could be something. It's basically RAID 5 for the network. So to be interesting to see what kind of solution they come up with.
Okay, we have a question over here.
3 parts. Do I need to use RAID in your file system? What is the role of SSDs, and how can I back up to tape?
We recommend to use RAID 5 underneath. You don't have to, but it sure makes it better if you do. There is a bit of a performance hit with that, but it's not absolutely necessary. And what was the second part of your question?
SSDs?
Oh, SSDs.
The role of SSDs?
They're fine.
And the third was how to back up to tape.
How would you back up to tape?
Or back up at all.
Yeah,
or back up at all.
You can, well, because it's mostly POSIX compliant, you can use anything that understands POSIX. So if your backup software understands POSIX, then it should just work.
Right. RAID.
So ceph is completely, not completely, but almost entirely agnostic of what hardware you're sitting on. So you can run it on top of the slowest, crappiest SATA disk you can get, or you can run it on top of Fusion IO, and your performance will vary accordingly. If you use RAID, you can put ceph either on top of a raw disk and you rely on ceph's replication in order to deal with failure, or you can put it on top of a RAID array that is essentially just more reliable and bigger, but you pay the 20% or whatever overhead for the RAID code. Currently, we recommend just running on top of raw disks because it's simpler to deploy, simpler to manage, and the performance tends to be better. But people do it both ways. For ceph, you can run the whole system on top of SSDs. A lot of people do that, and they get great performance. If you can afford it, that's certainly a preferred solution. Some people run on only disk. That's good. But the sort of the sweet spot as far as the price performance for ceph is to use a disk for the data and use SSD for the journal. And that gives you fast, low latency writes, but it also gives you the capacity of the disk. There was also a user recently who was experimenting with using flash cache, which is a kernel module that uses an SSD as a cache for the hard drive, and using that in combination underneath the ceph OSD, and they got some great numbers too. So that's also something to consider. Sort of the premise when you're designing these systems is that if you have a multi-petabyte file system, you don't back it up. You can't afford to because you don't have another petabyte system to. The replica is the internal redundancy inside the system is the backup, and that's sort of how all of these systems are designed. Now, the dirty little secret of the whole distributed systems community is that we all talk about eliminating single points of failure and designing around that and so forth. There's one common element across the entire storage system, and that's the software. And so a single bug on any node can wipe out all your data. So you might do everything you can to deal with hardware failure, but if you screw up and deploy the wrong code, then you can still lose everything. So that's something to keep in mind. If you have...
They don't sell tapes that big.
They do sell tape robots that big, though.
Yeah. One fun note about backups. Generally speaking, we try to tell customers not to worry about backup software, but of course they don't believe us. But if you do use glusterfs for backups, we generally suggest using the geo-replication, the asynchronous replication for that purpose.
So my question is actually a little bit away from all the technical stuff. I'd like you to each defend your governance model and your, so on the one hand, we have a small startup that determines the fate of that open source project in a way. And on the other hand, we have Red Hat, which sort of, I know that Gluster is invested in a board and a governance model and everything, but yet there's some conflicts of interest there where Red Hat has thrown its weight into the OpenStack camp, and has its own products, its own hypervisor, whereas ceph is much more independent. So I'd like you to each kind of defend your governance.
Okay. That's actually a really good point. I'm glad you brought that up. Because when I look at things that ceph does that I admire, one of the things that they do that I really admire is their ability to do outreach with all these different communities and do the necessary integration work with all of them. I wish we were in a similar position. Having said that, I defend the fact that we have a pretty open governance model, and that we have, we do a lot of, we make sure that the community's interests are part of the process in defining what happens in the project. And I can tell you that when it comes to defining new features in the next version of glusterfs, we're not working off of PRDs that come from product management. It's the engineers getting together deciding what are we going to do to make the software better. Having said that, expect some changes starting next month, where we're going to talk about being even more open and even more inclusive, and moving away from a Red Hat dominated model to a very much open and something that's bigger than Red Hat.
So governance and licensing is something that I care a lot about. Part of the reason why I started ceph was because I was very frustrated with the proprietary storage industry, and so I wanted there to be a pure open source alternative to that. And so the license for ceph is LGPL, so it's copyright, copyleft. You have to contribute all your changes and change them and so forth, but at the same time it's LGPL so that you can still integrate it with other stacks. And the reason for that is because we view the storage layer as one piece of a much larger stack. You might be integrating it with something like Hadoop, you might be running it with KVM or QEMU or something like that, and you want to be able to work in all those environments. As far as governance goes, we don't have any board or anything. I'm essentially the benevolent dictator for the project. I'm currently the gatekeeper for my version of the ceph tree. Obviously, anyone can fork it, but at this point, most of the most active developers on ceph all work for Inktank, our company, and so our development efforts are somewhat guided by sort of Inktank's goal to bring it to market. That said, I was very careful when sort of constructing this company and choosing the people to run it about doing something that was sort of invested in a long-term, building a storage system that was a long-term solution for sort of distributed storage problem in Linux, because I think that's the most important thing. With respect to integration with other projects, for example, CloudStack and OpenStack, we've been very careful not to pick winners. OpenStack gets all the press and all the buzz and all the love. But it's funny that CloudStack is actually the one that's been deployed in all the largest environments. And then there are all these other ones too. There's things like Ganeti and Eucalyptus and all these other projects. So I don't think it makes any sense as an open source project to sort of choose who you're gonna integrate with and so forth. In fact, one of the key advantages of being an open project and not being sort of a closed source something offered by VMware or something is that you actually can integrate with all these things, and there's sort of a frictionless integration. The CloudStack integration for ceph, for example, was contributed by somebody in the Netherlands. Doesn't work for us, and he's been a ceph user for a long time, but he's not associated with Inktank at all. So, yep.
I would like to go back to the building blocks. We briefly discussed that in regards to disk subsystems, but I was wondering what CPU to disk ratio would you recommend for your system, and what amount of RAM?
It depends on your workload. Yeah, so what we've been typically deploying are nodes that have maybe 8 to 12 disks in a node, 4 to 8 cores, maybe 16 gigs of RAM, something like that, and that seems to work well. But we have sort of limited data points as far as what workloads are running against that hardware and what performance people are going to need. I think as the project develops, it'll become more efficient, and so it'll be able to run with less CPU as we continue to optimize it. We've done a lot of work trying to get it to run on some of these big boxes that have 36, 48 drives in them, and trying to get the full throughput of all the disks. And the problems we're hitting right now are, I think, related to like NUMA issues and asymmetric memory and all that annoying stuff that I don't really want to think about. So I think time will sort of tell.
We have very similar requirements. In general, we recommend anywhere between 4 and 16 disks per server node. We don't recommend more than that, just because once you add more disks into the mix, I/O tends to get squelched as you divide it up between all of them. But it does depend on the use case. It depends on whether your particular use case is more of a scale out versus scale up. For scale up, we tend not to do as well, so we try to push people to scale out as much as possible.
I think the thing to keep in mind too is that usually these boxes have a small number of Ethernet ports, and so the more disks you cram into the box, the less of a pipe you have to get at your bytes. So.
Yeah, hi. Interested in comments from both of you regarding your system documentation and what you would do to your documentation that you would like to have done to your documentation.
Man, you just had to ask about documentation. That's it, I'm out here. So what exactly do you want to know about our documentation? Sorry. I'll be the first to admit that our documentation is not great. If you want to help us build out our documentation, I would love to talk to you afterwards. But we have some pretty good getting started documentation. But once you start getting into the internals of glusterfs and how to actually do more than just your simple deployment, we kind of suck. So we definitely need to build that out. And if you know of any good documentation writers looking for work, I want to talk to them. So.
The documentation for ceph used to be horrible. Now I think actually it's okay. I don't know, maybe other people would disagree. it's very hard to find good technical writers who actually understand what they're writing about, and it's also very hard to motivate developers to write documentation instead of code. And so documentation is actually one of the easiest ways to contribute, I think, to projects like glusterfs and ceph. Yeah, I don't know.
How hard or easy is it to dynamically extend the size of the file system in an automated fashion? I have an example use case if it helps.
Very easy. With ceph, you essentially plug in a disk, you run a command to initialize the node, and then you run another command you start the daemon, and you run one more command to sort of add it in.
What about in the cloud context, so like dynamically extending the size of your cache by adding more nodes that have transient disk? You're just adding that transient disk to an existing file system.
Mm-hmm. So the sort of the raw level of what the nuts and bolts of what you're doing is running a few commands and adding it in. One of the things that we're working on right now is sort of an automated provisioning infrastructure. So you would literally, you would have a pile, the vision essentially is you'd have a pile of spare disks in your data center. You would plug it into a machine and you'd basically mark them all as empty ceph disks and then they'd be ready to go. And then as soon as you have a disk failure or you deploy a new node in the system, when you plug these guys in, they have a UUID on the GPT partition table that will trigger a UDEV rule that essentially will run the command to initialize the node and start the daemon, and it'll automatically join the cluster. If you have a host fail, you pull the disk out and you plug it into another host, and it'll re-add itself and start up on the other node. And if you have a failed disk, you just rip it out. That's sort of the high-level vision for how you manage, an entire data center worth of spinning disks in a sort of a scalable, efficient fashion. And we're sort of polishing the tools right now to sort of make that the default way that people use it. Right now, people are still using sort of the old, previous generation of tools, and we haven't quite transitioned to the new goodness yet.
So you can do a command gluster volume add brick, and that brick can either be on a new server node or it can be just a separate disk that you've added to another server node. And if you need to replace one, then use gluster volume replace brick, and it will do the right thing most of the time.
Okay, we're going to use a slightly unfair queuing scheduler for the next question, just such that Tim doesn't have to run around quite as much. So we'll take the question in the back and then the one from John.
So I was wondering what the largest installation of your file systems you're aware of in terms of the amount of data managed. I was also wondering if there are any gotchas or things that you weren't expecting to find when you deploy these kind of file systems in large scales, like managing 5 to 6 petabytes of data. I'm sure the number of disks change your attitude, for example, to using software RAID, hardware RAID, things like that.
I think once you scale up to a certain point, you start to run into some I/O difficulties with the control path. The data path itself can scale up to many nodes, but you start to push up against the boundaries of the control path, the ability to adequately manage in a performant way all the different server nodes you just added to your cluster. So I'd say that's one gotcha. I would say that for distributed file systems in general, these are still early days. There are all sorts of things that can and do go wrong. And the main thing is just that you have a flexible enough setup that you can take care of unforeseen circumstances.
What's the largest deployment?
The largest deployment.
Oh, largest deployment? I think supposedly that I know of, it gets into somewhere between 10 and 20 petabytes. There's a life sciences group at a major university. They've deployed genomic sequencing in a setup that's over 12 petabytes and pushing 15 pretty soon. Server-wise, there was a company in Taiwan that had a 500 to 600 node setup, but I think they had some significant modifications to push it down.
The largest deployment that I've worked with directly is the DreamHost DreamObjects one, and that's 3 petabytes. I've heard talk of larger clusters through SIs, but I haven't actually interacted with those clusters. I don't have actual numbers. What was the first question?
Gotchas. No, that was the first question, and the second one was gotchas that you're aware of.
I answered it first.
I think as you push the scale of these systems, regardless of how you architect it, you always run up against things that you didn't think of in terms of the implementation. And as you sort of continually push the line, you have to sort of iron out these wrinkles. And so we fixed a number of things as we sort of built that initial 3 petabyte cluster. I imagine when we build the next one that's 5 and 10 petabytes, then we'll find more issues. But there's nothing that I'm terribly concerned about, I guess. As far as gotchas, I mean, there are many ways to sort of misconfigure the system, I guess. If you don't choose your initial number of placement groups in ceph, it can be problematic, although the new version finally has splitting, and so you can, if you choose a number that's too small, you can split up. But if you choose a number that's too large to begin with, it won't sort of merge back down again. So we've helped a number of people who sort of box themselves into a corner in that way. That's probably the easiest way to run into problems.
Okay, we're technically over time, but we'll take 2 more questions from John and Steve.
So clearly, it's self-evident that distributed file systems are an evolutionary dead end, and the future is only going to be distributed block storage and distributed object storage. So how do each of your projects live in a world like that?
I think ceph lives very well in a world like that. So when we designed the file system, we decided the best way to do that would be to build a distributed object layer and then build higher level services on top of that. So ceph is actually a distributed object with native object, RESTful object, block, and then also a distributed file system. And ironically, the file system is the thing that we worked on first. That was where I began my sort of research, and it's the least stable and the one part of ceph that we don't recommend running in production just yet. That said, all the other parts are awesome, and you should run them today, especially over something like Swift. They're so much better. Yeah.
It's funny because over time, we only started to really focus on the scale-out NAS files and folders bit after venture capitalists got involved and told us to focus on that. Before then, we're kind of a bit more multifaceted. We're getting back to our roots and becoming more multifaceted. And so the scale-out NAS part, the files and folders part, is probably the best aspect of glusterfs at this point. And people are going to be using file servers for a long time, whether we like it or not. POSIX sucks, I hate it, but it's there and it's not going away, unfortunately. Having said that, we're all about creating a unified backend. And so we love to work with technologies like Swift. We like to push the Swift API. We like to push the Kv integration that we're doing. The libgf API piece lets you bypass Fuse, which is what we want to use for our SAM integration. So we understand that to really be a file system for the future, we have to move beyond the scale-out NAS bit, and we're working very hard to get there as soon as possible.
I think the one thing to sort of say as a general point about file systems in general is that when you look at sort of the marketplace, you have sort of the open source options, and then you have the proprietary options. The problem that the proprietary solutions have is that they're stuck with standard protocols like NFS and ceph, which are decades old and are designed with this basic client-server paradigm. And it's very hard to make something that is scale-out that is using a client-server protocol, because the client thinks it's talking to one person and not 100 different servers. And so this is one place where open source solutions can excel, because they can innovate on the protocol level and they can innovate on the client side, particularly in the Linux kernel where the proprietary solutions can't.
What are you talking about? I heard NFS 4 is going to be ready this year.
And PNFS.
Right, you guys have possibly touched upon it with the question just now. Just stepping back for a moment to the kind of position of rebuttal is for you to identify, quite at a high level or kind of a feature level, a gap in the other technology. And then the rebuttal is to kind of come back and say where you are in the roadmap, where you are going to address that gap in your technology. So,
if I understand the question correctly, a gap in our technology that they've done.
A gap, you identify a gap in ceph, and then ceph has to say where they're going to go and fix that, and vice versa. But this is at a very high level in terms of the feature capability of each other's technologies.
Correct me if I'm wrong, but I think I'd like to know whether or not storage backend is something that you want to solve for future versions. The ability to store the same type of data and available via different protocols and access points.
So that's something that ceph doesn't do, obviously. If you're using the object API, then you're talking directly to the low object layer. If you use files, and you're talking to the higher level. Even though it's stored in objects, you can't access the same data via both APIs unless you're sort of hacking around things. I don't think that's something that we're going to change. I think that if you want to store something that's accessible via both an object API and a file API, you would layer something on top of a file system, and it'd be something that you'd run on top of everything else. And I don't think we'll change that because I'm not sure that it's as nice as it sounds. It's not something that people actually need. And when you actually think about those different APIs, you optimize them for them in completely different ways. So for the RESTful APIs, for example, we want to be compatible with Amazon S3, and listing a directory gives you things in alphanumeric order. That's not how people interact with file systems, and I don't think we would ever want to do that because we need to do things like hashing and so forth. And so it doesn't really make sense to enforce sort of the lowest common denominator of both APIs on all data.
And now you get to identify something in Gluster that's missing.
Snapshots?
Yeah. No, we're looking at working with things like on a lower level disk file system. But for distributed snapshots, that's probably something that we're not going to be able to do for a while. And we're still working on what the best implementation is.
Yeah.
All right.
They're hard.
So I guess we'll close it here. Thank you very, very much for coming. Thank you to John Mark and Sage for taking the questions and for talking.
Thank you to Florian for doing a great job.
I should thank Jeff Darcy for the shirt.
And this also rounds out this mini-conf, and I believe that Tim has some closing remarks and something interesting that's happening tonight.
Yeah, so just quickly, given that this is closing remarks, I'd like to thank Joe and Dan and Thomas and Phil and Kim and John and Jamie and Stephen and Daniel and Florian and Sage and JM for all of their talking and everything. I'd like to thank the AV crew, room guy, Richard, sorry. Bios of all these people are up on the wiki page. I'll get slides from people who want to give them to me, and I'll put them up there as well, so they'll be there soonish. Thank all of you for coming. And in half an hour or something probably, there's a thing on at the Wigan Pen which kind of sold out. And I'm sure that some of you are coming, and some of you might not be able to, I'm very sorry. Did I miss anything? No, that's it. Good.
There are a few things that you may not know about glusterfs. Let's start from the beginning, and kind of an interesting beginning, because we never set about to be a storage company when we were Gluster Incorporated. We never set about to write a distributed file system, at least not initially. Some would say that that's apparent in the current code, but I would disagree with that. But seriously, from the beginning, we were we were responsible for creating clustering software for HPC solutions, and a lot of that was for oil and gas companies. And then one day, I think in around 2006, 2007, there was a company, and it was an oil and gas company in South America. They needed something done. They said, hey, by the way, can you do this distributed storage thing? And we did it in 6 months. And being a cash-strapped startup, as cash startups do, we said, yes, of course we could do that. Not really understanding at all what that would entail. So we thought we would just pick something off the shelf, install it, get going, and be fine. It turned out it wasn't that easy. We tried to use something off the shelf. We discovered that proprietary software was extremely expensive and difficult to use, especially for that use case. And one thing about it, the great part about it was the performance requirement was it had to be faster than tape backup. As long as it's faster than tape backup, we were good to go. So had to be distributed, had to be allowed.
Services business on top of ceph. He's based in LA. Sage is a strong proponent of a standing desk arrangement in his office, which makes video calls with him really, really interesting in a hoppy, bouncy way. He has a gigantic whiteboard behind him to draw out his design and implementation ideas, and rumor has it that this whiteboard has never been empty. As for myself, I'm Florian. I run Hostexo, which is a company that does projects with both of these storage technologies. And I will be doing today what is the absolutely hardest thing for me to do on anything, and that is have no opinion and shut up. A few words about this format that we're doing this afternoon. This is a debate, which means it's not a Q&A session, and it's also not a fight, but something halfway in between. We're going to start with giving each of our presenters 3 minutes and no slides to give us their summary of the project that they represent. And after that, we will start with the questions. And whenever you have a question, then please just raise your hand and wait for Tim to race up to you with the microphone. And of course, when you have questions, then please try to be as precise as possible and put our speakers on the spot. Huh? We'll kind of try to...
Florian, who is going to moderate this amazing debate.
Okay, thank you, Tim. So to round out this mini-conf, we thought we'd get two of the people that are representing, in my humble opinion, two of the more exciting distributed storage technology projects that are in the open source community today, and let them have a go at each other, which is exactly what we're going to do now. So let me just start by introducing the most important people on the stage here today, which are my two debaters. To be fair, in alphabetical order by surname. John Mark Walker in the Gluster camp, and Sage Weil in the ceph camp. Now let me introduce these guys to you real quick. John Mark is I think it's fair to say, a veteran community person in the free and open source software space. I know that's dating you to a certain extent, but you're just going to have to live with that. If I got your biography correctly, you spent a significant amount of time at VA Linux, correct? And that's basically, he was in the SourceForge and Slashdot and whatnot space for quite a while. SourceForge, that's right. Before joining then independent Gluster Inc. And then he was to be apprehended along with the rest of Gluster by some secret agents wearing red headgear. He is based on the US West Coast. East Coast? What was that? Ah, you moved last summer. Okay, my information is outdated. What I do know about John Mark, however, is that he's not exactly a person who is known to keep his views to himself, which is quite evident from his Twitter feed. He has relatively strong opinions on US economic policy. It's quite interesting to follow. He is also, and I hope this is not wrong, he's also an avid follower of what one half of the English-speaking world calls association football, and the other soccer. Sage Weil, to my right and your left, he is the technical lead of the ceph project. He is one of the founders of DreamHost. It's a hosting provider located in Southern California. And in the mid-2000s, took a break for some postgrad work at the University of California, Santa Cruz. And this work resulted in a PhD thesis, which ultimately became the basis of what the ceph stack is today. Since 2012, he's been in a leadership role at Inktank, which is a company that spun out of DreamHost in order to build a support and they'll alternate who's the first person to answer the question, and the other person will always get a chance to answer or rebut or whatever they choose to do. Heckling is perfectly allowed, as long as it's good-natured and as long as we are being excellent to each other. You done yet? Almost. Almost. So before we dive into our questions, every one of our two speakers is now going to get 2 minutes to describe what they think, 3 minutes, I'm sorry, to describe what they wait for a second, you get 1 minute. To describe what they think is what everybody should know about their project. And in the interest of fairness, I thought we were going to do a coin toss to determine who goes first.
The suspense.
So let me pull out my, there we go. What, seizure?
Seizure.
Yeah.
Flickering. Oh, that.
There we go. Okay, John Mark, heads or tails?
Heads.
Heads. There we go. And it is heads. John Mark goes first. There we go.
Greetings. Do I need this thing to be on, or is it necessary?
Yeah, for the video.
Okay, I'll just try to hold it down. Thanks. Yes, my name is John Mark Walker. I'm the Gluster Community Lead